Hi guys, welcome back to Business Statistics. This is the video for 3.3, the addition rule of probability. We're just going to get right into it. The addition rule of probability states that the probability of event A or B occurring is the probability of event A plus the probability of event B minus the probability that both events occur as the single outcome of an experiment. Okay? That's going to become more clear of what exactly that means. But essentially what you're doing is when you add those first two probabilities in, the probability of event A and then the probability of event B, what you end up doing is you end up double counting the spot where they overlap. And so then the last part where you're minusing off the probability that both events occur as a single outcome of the experiment, this is when you are minusing off that second overlap so that you just have counted it one time. So that formula is going to look something like this. The probability of A union B, okay? And this U stands for union, but the way that you can read it is you can read it as or. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A, and upside down U is and B. So this is the probability of A or B, and that's equal to the probability of A plus the probability of B minus the probability that A and B occur at the same time. Okay? And I think I just mentioned, we're minusing this off because within A and B, this has already been counted twice, so we just want to minus it off one time to get it down to be only calculating, for us only to be considering it one time. Example 1. In a math class of 20 students, 11 are boys and 9 are girls. On a test, 4 boys and 2 girls received an A. If a student is chosen at random from the class, what is the probability of choosing a girl or an A student? Okay, and so then two types of probabilities that we have, I guess, that we will name. We could say you could be a boy or a girl. Okay, so they will have certain probabilities associated with them. And then we can have an A or not an A. Okay. So then we can associate probabilities with these. So we would have probability of being a boy, just say probability of B, and that is going to be 11 of 20, right? Because there's 20 students in the class and there are 11 boys. Probability of being a girl, and that is 9 of 20. Probability of getting an A on a test, well, there was 4 boys that got A's and 2 girls that got A's, so there's 6 A's. So we'll just say probability of A is 6 of 20, and then we'll just say probability of not A, which is going to be the people who didn't get it. We'll just say not, I guess, and that'll be 14 of 20, right? And so now this asks us, what is the probability of choosing a girl or an A student? So that girl can be an A student, but it's just saying or, so girl or an A student. So we get probability of girl union A student, which is just equal to the probability of G girl plus the probability of A student minus the probability where they intersect, okay? Because that is where we would be double counting by already counting this P of G and P of A. So probability of G, we already have this, so we have 9 of 20. Probability A, 6 of 20. And the probability that we're getting rid of where they intersect is girls that received an A, right? So girls that received an A were 2. So the probability that they intersect would be girls that received an A, so 2 of 20. Okay, so this fraction is 15 of 20 minus 2 of 20, which is then 13 of 20, or 0.65. So 0.65 is equal to the probability of getting a girl or of getting an A on the test. But that can count for girls that get A's on tests. But we minus it off for the double counting. Okay, our next example. Some of these videos we're going to do multiple examples in a row, and then I'll do multiple U tries in a row, and this and that. So, okay, for this example, 2 customer service centers for a credit card company in Texas. Center A and Center B receive calls from customers in 3 states in the western part of the United States. A breakdown of the number of calls received at the 2 centers during peak hours on one particular day by state is shown below. What is the probability that a randomly chosen call comes to either Center A or is from California? Okay, so let's just write down what it's asking us. So it's probability of Center A union, say Cali. Okay. And we know from our rule that is the probability of Center A plus the probability of it coming from California minus the intersection of both of them. Okay. So now we're going to look at our table to pull out these values, okay? So whenever we're working with probability, it's going to be the number of occurrences divided by the total, right? So our total here, our big total is 218. So the probability of something coming from Center A is just going to be that marginal total, so 113. And then turning that into a probability, we just divide out by the total. And then the probability of California, so we go to California and we find the marginal, 85. To get the probability, we do divide out the 218. That is a 5, I promise. And now, this probability of Center A and California, okay, the intersection between the two is going to be the intersection in the table between the two. So we're looking at Center A right here and California here, so we get 40. 40 is our intersection point. So it's just going to be 40 over 218. So we get 113 plus 85 minus 40, and that's going to be 158 over 218, which is roughly equal to 0.7247. Okay, now you try. What is the probability that a randomly chosen call comes to Center B or is from Washington? Go ahead, pause the video and try that one on your own. Okay, hopefully you had a chance to try that on your own. So we'll just say the probability of B or is from Washington. Okay, we're just going to plug this into our addition formula, which is the probability of B plus the probability of Washington, minus the probability of their intersection. Okay, so we're going to get the probability of B, which is, if you guys are following along with your companion worksheet, you can see that it's 105. because I know that it's not on the screen here. And the probability of Washington is 78 over 218. And the probability of their intersection is 31 over 218. And that is going to equal 153 over 218, which is a fairly similar number. And that's going to equal roughly 0.7018. So now we'll do another example. Example 3, in a certain company, the probability that an employee walks to work on a particular day is 0.17. And the probability that he or she takes public transportation is 0.4. And the probability that he or she drives to work is 0.43. If an employee is chosen at random, what is the probability that he either walks or takes public transportation to work on a particular day? Okay, so this is kind of getting to an interesting, or maybe uninteresting, little facet to this rule. So what we've been looking at is the probability of A union B, and we've been saying, well, that's equal to the probability of A plus the probability of B minus the probability of A intersect B. Okay, but if you look closely at this problem, you notice that, well, what I will say is this rule can be applied more generally as well to multiple probabilities, so A union B union C. So right, we've got 3 different occurrences here. But the main concept is that we notice that these probabilities are all mutually exclusive, right? So A and B, or B and C, or A and C can never occur at the same time. So what ends up happening is we can kind of just throw away this intersection point because we know that it can't happen. So then for mutually exclusive events, A union B, okay, is just equal to the probability of A plus the probability of B. Okay, so what is it asking us? If an employee is chosen at random, what is the probability that he either walks or takes public transportation to work on a particular day? So we're going to say, so it'd just be the probability of A, or the probability of walk union public transportation. Okay, and we'll say the probability of walk plus the probability of public transportation. And the probability of walk is 0.17. The probability of public transportation is 0.40. So then, thus, there's no intersection point, so it's just going to be 0.57. Simple enough, right? So we just saying, well, we're going to minus off where they overlap. Well, but if they don't overlap anywhere, then you're just minusing off 0, so you might as well ignore the term. And then lastly, go ahead and do a U-try. This is more of a theoretical type problem, or a little less concrete. But go ahead and do the U-try. Okay, hopefully you were able to pause and had time to go through this problem. What is the probability that a game player will land on an even number or a number divisible by 3 in a game where the spinner has 9 equally sized spaces numbered 1 through 9? Okay, so the first thing I like to do when they give us a problem like this is just to write down like what our options are. So there's no formula for this. This is just how do we attack a problem like this. Okay, so we have like this thing that's, they're evenly sized spaces. You can maybe think of this as like some sort of like, circle, some sort of spinner, some sort of pie chart, like that sort of thing. But just know that they're equally sized spaces. These are the numbers that are on those spaces. Looks like there are 9 options. Okay. And so now we just have to now create probabilities that are associated with these, right? So first of all, let's do that. So it's asking, what is the probability that a game player will land on an even number or a number divisible by 3? Okay, so let's find, what's the probability of having an even number in this set? Okay, well, how many even numbers do we have? We have 1, 2, 3, 4, and then we have 9 total. So the probability of landing on an even would just be 4 of 9. Okay, and now we say, okay, well, what's the probability of landing on a number that's divisible by 3? Okay, well, we have a 3, we have a 6, we have a 9. Okay, so we'll just say the probability of, let's say div 3, okay, is equal to 3 of 9. Okay, well, what is now the probability that they're both divisible by 3 and even? Okay, so the probability that even and, so even not union, but even intersect div 3, well, of the divisible by 3, the only one that's even is 6. Okay, so 6 is our guy there, right? So probability is just 1 of 9. There's only one option out of the 9. So now we can apply this to our formula, right? So our probability of A union B is equal to the probability of A plus the probability of B, the same one that we've been using, minus the probability of A intersect B. Okay, well our A's and B's are evens and divisible by 3's, right? So this is then the probability of even or divisible by 3 is equal to the probability of even plus probability of div 3, I guess, minus the probability that it's even and divisible by 3. Okay? And that's just going to be our 4 of 9 plus our 3 of 9 minus our 1 of 9, which then is going to give us 6 divided by 9, or 0.6666666, all the way, out there. Okay? So that's that, guys. This would conclude our lesson on the addition rule of probability. If you have any questions, concerns, issues, if I made a mistake, I'm not perfect, so sometimes on these I'll make mistakes. Please let me know in the discussion board, email me, anything like that. I want you guys to learn this as best as possible, and that's why we're kind of giving you a bunch of different examples, but use these videos as a study tool, use the companion worksheet as a study tool, use the PowerPoint slides, use the Learn Smart Achieves. You can use that really, really, really great ebook, #sarcasm. But yeah, you've got multiple sources. If you find other sources that you like to use, go ahead and post those in the discussion board, just to help out other students. But hopefully you found this helpful. But yeah, hopefully you guys can give me some feedback kind of on these companion worksheets if you like them. If you don't like them, I appreciate the feedback. All right, thanks so much, guys. And next one will be 3.4. All right, thank you. Bye.